Good morning, good afternoon, and good evening, depending on where you're joining us from. My name is Kim Everhart, and I am a member of the marketing team here at Percona. And I want to thank you for taking some time out of your day to join us for our webinar on tuning Postgres for high performance and optimization. And that is with our own Ibrar Ahmad, who is a senior database architect here at Percona. And before I turn it over to him, I'm going to go through a few housekeeping items just so everyone is kind of aware of what's happening and how we're going to proceed today. So first and foremost, this webinar is slated to be 90 minutes. So if you have to leave at any point or you can't make it the whole time, we are recording it, and I will be sending a recording out within the next 24 to 48 hours. We welcome questions, but everyone is muted, and we request you stay muted. Just it makes it a little bit easier to minimize background noise and all that good stuff. Before I kick it off officially, I'd like to do a sound check with everyone and a visual check. So I know it's kind of a silly thing to ask, but if you can hear me talking right now, can you raise up your little hand icon? Awesome. All right, so many hands went up. That's great. I know I hate asking that because obviously if you can't hear me, you can't raise your hands, but that's how we'll know for sure. And then I'm going to ask Abrar also to say a few things so we can check on his sound as well.
Hello, everybody. So I think everybody can hear me.
So if you can hear him, can you just raise your hand icon back up? Awesome. Okay, looks good. I see lots of hands going up. So my last check before I turn it over will be a visual check. Can you guys see the screen? And you know, it should be the first slide deck for the webinar. If you can raise your hand and indicate you can see that. Perfect. All right, so then we should be good to go. So we welcome questions, as I mentioned, so please go ahead and drop them into the Q&A window or the chat, whichever one. I'll be monitoring both, and then we'll save them towards the end. If for some reason we run out of time before Abrar can finish, I will send him any questions that are remaining, and he'll answer them, and we'll put them together into a blog on our blog site, along with the copy of the recording. So that's it for me. So Abrar, if you're ready, I'll hand it over to you. Oh, I think you're still muted. Oh, there we go.
Yep, I'm just listening to you. So, hello, everybody. Let me minimize it. Hello, everybody. My name is Ibrahim Ahmed, and today's topic is tuning PostgreSQL for high performance and optimization. So basically, we will see how we tune PostgreSQL to get the best performance from the PostgreSQL. So my name is Ibrahim Ahmed. So let's get started. So who am I? I started my software career since 1998, and I've been working with PostgreSQL since 2006. I started my career of PostgreSQL from Enterprise DB, and in 2018, I joined Percona as a senior database architect. So here is detail of my LinkedIn, my Twitter, my Facebook, and my personal website addresses there. I authored multiple PostgreSQL books. One is PostgreSQL Developer's Guide, and second is PostgreSQL 9.6 High Performance. So what is the agenda of today's webinar? So we will discuss what is a database performance. So we will see when we want to get the best performance from the database, what should we do to our database, to our operating system, to our application, to everything. We will see how we can get the best performance from the database. Then we will see what module PostgreSQL have and which module we can optimize. Then we will see the PostgreSQL performance tuning. We will see the performance tuning parameters for PostgreSQL. And then when we tune PostgreSQL, then we will see in the Linux kernel tuning. We will see which parameter of Linux kernel can be tuned to get the best performance from the PostgreSQL. After that, I did some parallel query optimizations because it's a new feature. So I really want to touch that feature, that we have some configuration parameter in PostgreSQL.conf file. We will study what is PostgreSQL.conf file, in which we can configure to get the best parallelism from PostgreSQL. After that, we will have a question answer session. So we already discussed that it's a little bit lengthy webinar, because the last time when I did that, it's 1 hour, but 1 hour is not enough for that. So I just have more than 1 hour. It's 90 minutes, 85 minutes, 90 minutes webinar. So I will spend on 10 minutes on database performance and 20 minutes on PostgreSQL module, 30 minutes on PostgreSQL performance tuning, 20 minutes on Linux kernel tuning, and 10 minutes parallel query optimization. And in between, 5 minutes on the tips, and rest of the time is for the QA session. So database performance. So first topic is database performance. So when we are talking about the database performance, the most people has misconception that when we have a database, if we tune that database, then we will get the best performance. That's wrong. Why that's wrong? Because database alone cannot be tuned, cannot perform in the best way, because it has many things attached to it. So first thing is the hardware. If you have a better hardware, or you can have the best hardware in the world, then you can run database very perfectly on that. So, but there is a limit. You cannot have everything in hardware, because it requires some cost. You need some dollars, more dollars to spend on the hardware. So if you add more dollar to the hardware, you have multi-core processor, unlimited GB of RAM, then your database perform really well. But as I'm telling you, that this requires a dollars, a money, cost. So you have to limit yourself that we have this kind of a hardware, and the database should work perfectly on that kind of a hardware. So you can put your resources or your money to buy a best hardware for you to perform a better way for the database. Then the second thing is the operating system. When you already finalize your hardware, then you have to think about what is the best operating system for your database. Because previously, a long time ago, when people don't have too many computers, they are using application and database on the same computer. But now we have a dedicated computer for the databases. So when we are talking about the databases, then we need a separate hardware and separate operating system on that. So it doesn't matter if you have a Linux on the database and your application is on Windows. And doesn't matter if you have a database on Windows and you have application on Linux, because everything works on network. So now you have to carefully choose your operating system. So your operating system depends on three things. One thing, what kind of a hardware you are using. Second, what kind of a database you are running on that, and what is the type of your workload. So we can't say that if you have, why I'm saying that it's dependent on your hardware, because if you have something like you have a MacBook, you can't run Windows on that. Forget about the virtual machine and everything. You can't run Windows on that, or Windows is not meant for the MacBook. So you have to choose your operating system according to your hardware. Then you have to choose your operating system according to your database. Like if you want to run PostgreSQL, Linux is a really good operating system for that. You can run on Windows, but the performance on Linux is much better than the Windows. But it doesn't mean that you cannot run that on Windows, but you can, but you have to choose wisely. So third thing is your workload. You have to see how big workload you have. If you want to buy Windows or not, you want to use a free software or not. So you have to choose your operating system. And the third thing is your database. So now you have to choose your database wisely. Like if you need a database, a document database, then you have MongoDB if you want to have a Hadoop and everything, but you know your application type, so you choose your database. In this case, we are choosing the PostgreSQL. So in that case, we will tune our post database, which is PostgreSQL. So after choosing hardware, then you are choosing your Linux or Windows or HP UX or Solaris, any operating system according to your need. Then you choose your database. And in this case, we are choosing the PostgreSQL. Then you have to tune your PostgreSQL database. Then we comes to the application. Because after choosing the database, it's really important to tune your application. If you have a best hardware, if the optimum Linux or Windows operating system, and you tune your database optimally. Problem if your application is badly written, then you are not getting the benefit of very well tuned database. You're wasting all your resources. It's because, for example, the basic example is if you are running some constantly queries to the database, and on each query you are establishing a connection, and send a query and disconnect it and then establish a connection. This is a bad example because you're continuously sending the query, but in each query you are establishing a connection and disconnection. Sometimes it's neat, but when you are continuously sending the queries, it's not good to establish because you are wasting database time. So it's a badly written or untuned application can waste your effort of tuning your database, choosing your hardware, and choosing everything. So you have to tune your application accordingly. Then when you tune your application, then it depends on your workload. What kind of a workload you have. So when you choose your workload, it's when you choose a database according to your workload, then it's best. If your workload is like OLAP, then a database which is best for the OLAP, you have to choose that. And if you want, you have a document database. Workload type is if your workload is document type, then MongoDB is really good for that. But if you are OLTP, then OLTP database is good for it. So a wrongly chosen, a badly chosen database, which is not according to your workload, will not get you any benefit. Then the last thing, and which is the query. You already tune your application, tune your database. You have a best hardware, a best possible hardware, and you choose the best operating system for you, and the everything is good. But your developer is writing a bad queries, so you will not get any benefit from the database. For example, if you require a single record from the database and your developer is writing query like static from a table, which is foo, and then getting all the rows from the database and filter out and just extract the one row from that. Is it good? No, because maybe foo table has a millions of rows. So you are extracting millions of rows from table foo where you need only one row. So you have to write a very optimum and very good queries to get the best benefit. So these are 6 modules I have divided that will give you the best performance from your database. First one, your hardware. You choose your hardware best and you optimize your hardware. Then you choose your operating system based on your workload, and then you choose your database, you choose your application. Not choose your application, you tune your application. It's a client application which is communicating with the database. Then you are writing a best query for your database, optimum query for your database. So in this webinar, we will study how to tune PostgreSQL. The first topic, tune the PostgreSQL. Then we will study how to tune your operating system. And in that operating system, we will only take care of Linux. We will not study the Windows here. And then some part of the query. And basically, it's a parallel query because the new topic and it's for the optimization. So I will give you some hints and some slides over that how to tune your parallel queries. So we will not talk about the hardware and the application tuning and the workload. So we will not study that. So it's the main agenda of this whole webinar. So now PostgreSQL module. So here are the main picture of PostgreSQL. If you see, I have almost everything which is PostgreSQL. It's almost, when I'm saying almost, you may argue that there is something missing in that, but you can see the whole picture of PostgreSQL here. So the first we will study what is the clients. The client is an application which is connecting to the PostgreSQL database to query. It can be a pSQL query which is using a libpq protocol, which is a PostgreSQL built-in protocol and built-in library. So pSQL is a client available for PostgreSQL. You can connect and you can query that. Then you have a client which is connecting using JDBC. You have your JDBC application, Java application, which is using a JDBC driver to connect to the database. You maybe have a client written in C and some and running on Windows and any operating system and using ODBC to connect that. And there can be many other options available. PostgreSQL is a very rich database. So it has many options for the client's library to connect to the PostgreSQL. So why I'm talking about this? Because when a client connect to the PostgreSQL, we will study what happened to the PostgreSQL. So PostgreSQL is a process-based architecture. So what does that mean, process-based? Process-based means when you start your PostgreSQL, I think everybody knows how to start the PostgreSQL. There's many ways to use the service, PGCTL. So when you start the PostgreSQL, it starts a process called postmaster on default port 5432, which can be changed in configuration file, but default is 5432. And some other processes, checkpointer, background writer, logger, archiver, wall writer, and some more. And what is this Postgres process is doing here? Whenever any client connect to the port 5432 to the postmaster, the responsibility of postmaster, it spawn another process called Postgres and assign to that process to that client to communicate with that. Here we have postmaster running 5432 like pSQL, connect to the postmaster 5432. Then postmaster will create another process called Postgres, and this pSQL client will connect to this Postgres, and the communication will start, and you can query that and everything. So what does that mean? It means if we are running multiple queries, multiple session with postmaster, then it will spawn multiple Postgres. Like if 50 clients are connected to the Postgres, then if you can see in the background, 50 Postgres processes are running. I will show you in the next slide that how you can see that. So it means it's not a thread-based architecture. Normally, the application are written in a thread-based, but this is not a thread-based. When you connect to the Postgres, it will spawn another process, and you are communicating on that process. You're not communicating with the postmaster, you're communicating with that process spawned for you. So that's mean a Postgres process-based architecture. So why I'm telling this to you, I will let you know after some slides because it's really important. So disk management, how Postgres manage data over the disk. When you install PostgreSQL, everybody knows that there are sometimes you are installing the RPM or Debian package. It's did a initdb for you, and initdb, if it's not, and somebody you already know who are more experienced DBA, most probably you are, then they do initdb themselves. When you do initdb, it will create a data directory which you specify in pg data environment variable, or you can specify initdb minus d and data directory. In that data directory, PostgreSQL create a cluster for you, a database cluster for you, where all your database files, your global file, your database file, your configuration file, your wall file, everything resides there. There are options. You can have configuration file somewhere else. There is option to have a table space outside that data directory. But that's a different story. But you have to think, you have to remember, not think, you have to remember then when you create a PostgreSQL cluster using initdb, it will create a data directory and your database file resides in that directory. And this is the important directory for you. You don't need to touch that directory only. It should be secure enough. It should, they, most of the time, and the 99.9% time, you don't need to touch that directory. Only you need that directory to change some configuration option. That's it. Other than that, you don't need to touch that directory. So PostgreSQL memory system. PostgreSQL has its own buffer management system. So it has some buffers like shared buffer, wall buffers, work mem, maintenance work mem. It has its own memory management system. So whenever we are talking about the PostgreSQL, then we have to configure PostgreSQL memory management system. And when we are talking about the memory management system, then we have to configure it using its configuration parameters. And these configuration parameters are configurable, and we will configure these parameters, and we'll see what's the behavior of these configuration parameters in the next slides. In these slides, I'm just giving you the main overview. I'm just telling you that PostgreSQL has its own memory management concept, but it also uses Linux memory management or operating system memory management system. Linux, because and whenever I'll tell that talking about the operating system, it's Linux. I'm not talking about the Windows because it has some other concepts. So don't confuse if I'm talking about the OS. It's always Linux now in as far as this webinar is concerned. So it's a PostgreSQL also using a kernel memory because it's running on Linux kernel. So Linux kernel has its own memory management, and it has three parts. First part, it has pages, memory pages. And what you call the Linux memory pages are 4K. And the 99.9% these pages are used. But there is another concept, a huge page concept. And it is normally called classic huge pages, which can be a 2 MB or 1 GB. Either 2 MB or either 1 GB. And I think in the later research, it has more bigger one thing, 1 terabyte huge page is also available. And the third concept is transparent huge pages. So we will study the Linux kernel memory also in this webinar. So these topic we have discussed about the clients, about the processes, about the disk management, about the PostgreSQL memory and the kernel memory. And we will try to touch these one by one, the mostly the process, the PostgreSQL memory and kernel memory are specifically things which we can configure. And we will not discuss which we can't configure. So PostgreSQL use its default setting in that case. So the first topic, PostgreSQL performance tuning. These are the basic tuning parameter of PostgreSQL. So here I cannot discuss each and every parameter of tuning parameter of PostgreSQL because and where we can't configure that there is a file in PG data directory or sometimes it's an etc directory that it's called postgresql.conf file. And if you go and open postgresql.conf file, you can see many parameters there. These are all not the tuning parameter. There are configuration parameters. Some are tuning parameter. And I extracted some of the tuning parameter from that file. So there in that file, you can see to configuration parameter like you want to run the auto vacuum or not. So how to configure auto vacuum. Then configuration parameter doesn't have to do with the tuning parameter, but the tuning parameter and the configuration parameter both are in PostgreSQL.conf file. There is another configuration file, pghpa.conf. It is not a tuning file. It is for the security file. You have to configure which kind of security you want for which IP address. So it's out of question of this webinar. So we will study these configuration parameter in next slides. So one of the major tuning parameter is shared buffers. And what is shared buffer? PostgreSQL uses its own buffer along with kernel buffer IO. Linux kernel has its own buffer system, and PostgreSQL has its own buffer system. And this concept is called double buffering. So PostgreSQL use its own buffer and also use the kernel buffer. So it's called double buffering. So PostgreSQL does not change the information on disk directly. PostgreSQL writes its information into shared buffer cache, and a process and backend process pick that information from shared buffer and then write this information into kernel buffer, and then kernel pick that information from kernel buffer and then writes that information into the disk. This is called direct double buffer, double buffering. It's not direct IO. It's not like that when you insert a row into table, insert into something in food, it directly return to the disk. No, it will go to the shared buffer and then a process comes and then pick that information and they return in the buffer. Then it goes to the kernel buffer and then kernel pick that information and then this information in return to the disk. So there are a lot of steps involved in between. So, so how we can control this information? If we have the control information, we have a parameter. It's called shared underscore buffers. You can configure that in postgresql.conf file, and you have to restart your PostgreSQL when you change that information. A restart is required. So how big this buffer should be? It's all depend on your memory. And documentation said it should be 25% of your total RAM. But personally, I have more than 16, 17 years of experience. I talk many people. I don't agree with that because now we have a dedicated computers for the database. So on that computer, we are running only PostgreSQL, a database. So in that case, when we are running database, so if we are only using 25% of the memory for the PostgreSQL shared buffer, so what we are doing for the other part of the memory is waste. So there are two or three concepts to configure your shared buffer. Like one of the main author of PostgreSQL, Bruce Momjam, the discussion, he's also said the proper size of the PostgreSQL shared buffer cache is the largest useful size that does not affect your other activity. And mostly you are not doing any other activity on that database server. So 40% or 50% or 60%, it depends, and you can set that information. And in my logic, you have to learn which size is best for you. Mostly, if you don't know about your workload size, then 40 to 50% or 60% is good for the shared buffer. But the question is, if your workload size is like, if you have 100 GB of RAM and your workload is 50 GB, then if you set the shared buffer 50 GB, then your whole workload fit in the shared buffer. You will get the maximum performance for the database. So the minimum IO will happen in that case. So why you are setting 40 GB if your workload is 50 and your total memory is 100 and you are setting that to 40 GB? So you this parameter is really important to set, and you make sure and that the default is very low. And why it's low? Because PostgreSQL community wants to have a system PostgreSQL which can be run on minimum specs of hardware. If they set its default is 10 GB, so it won't run where that RAM is 2 GB. So they set that minimum values for the configuration so it can run on any system. So here I'm just showing the parameter value, but you have to set that value in postgresql.conf file, and you have to restart your PostgreSQL because the one-time setting, and then you can use that. The second important setting is max connections. The default is 100. I told you that in the next slide, I will let you know that when a client is connected to the PostgreSQL spawn, postmaster and postmaster spawn and another process, and then that process will communicate with your client. So here I launch a client with a PostgreSQL and just run a query there, and it's a three terminals. In the first terminal, second terminal, and third terminal, I open three terminal and open pSQL and run and check the process ID. It's just a function which can check which PostgreSQL process we are connected to. So you can see on the right side, there are three processes spawned for that, and each pSQL is connected to that PostgreSQL process. And the state is idle. So it doesn't matter idle what we are doing on that. So it's just example that if you, and default is 100, you cannot connect more than 100 process to the PostgreSQL if because default is 100. You can change it. You can change that to 200. When after 201, it will give you the error message. But the problem is, I have seen in production that people set it 5,000, 10,000. How PostgreSQL can handle 5,000 and 10,000 connection at a time? Because it has to create the one process per client. If you have set that 5,000 and you connect 5,000 client to them, and the 5,000 client are doing nothing, so what is the purpose of that? Maybe your operating system won't allow you to do that. So your hint is here. If you want too many connection for PostgreSQL, I use Pooler. There are Pooler available, and the best one is the PD Bouncer. Sorry, PD Bouncer. Then use PD Bouncer, and you can have many connection, as many as you want. But for the 5,000 and 10,000 connection, don't go with direct with PostgreSQL. It's possible you have a very large hardware, but operating system and hardware has its own limits. So PD Bouncer is a very good option for that. So here, sorry, slides in between your slides. So here's an example. I forgot about to give you the example about that. Like, sorry. Here, shared buffer versus TPS. Here I set 120 MB of shared buffer. You can see the TPS is very low. I start is a 500, and when I start increasing shared buffer, and you can see the TPS transaction per second is increasing very fast. So, but you can see after 4 GB, we are not getting a good performance. It's stable. Why? Because our whole workloads fit in the memory. So there is no need to increase that. 4 GB is enough because our total workload is 4 GB and we set it to 4 GB. So our whole database fit in the memory. So increasing to 8 GB, 16 GB, 32 GB won't give you any benefit of that. So when you choose shared buffer size, just make sure when you are touching your workload, there is no need to have more shared buffer. There is no need for that actually. Another parameter, which is a wall buffer. Do you have transactions? Yes, absolutely, you have transactions. So what is the wall? Write ahead log. Log your transactions. When you have a transaction, a wall, log your transaction. And in a sense that it put that information into the wall files. And this is 16 MB with 8K pages. So when you put your information, your transaction information, it put that information into the wall file first, and then wall file writes wall into the buffer, wall buffers, and these buffer are flushed to the disk. So when you write your transaction information, that this information is written into the wall, and that this information written into the wall buffer, and then these buffer are flushed to the disk. So you can configure it, you can change it and use it. So how big value should it be? Bigger, the hint is here, bigger value of wall buffer in case of lot of concurrent connection give better performance. If you have a lot of concurrent connections, give a bigger value of wall buffer, give you the better performance. So PostgreSQL tuning, another parameter, effective cache size. So one thing I want to clear here, when we are talking about the shared buffer, the first parameter, when you set your shared buffer size, make sure when you start your PostgreSQL, it will allocate that info, that size of the memory on startup. If operating system does not have that memory, PostgreSQL will not start. So when you set your shared buffer, you should have that amount of memory. So why I'm telling you right now? Because the effective cache size is not like that. It's used by the optimizer to estimate the size of kernel disk buffer cache. It's just an hint for the optimizer. So when you set a bigger value for the effective cache size, it will not allocate that kind of a memory. It's just a guideline. So like if you set shared buffer 4 GB and you start postgresql.com, then you must have 4 GB of RAM in that case. But when you're setting effective cache size of something like 8 GB or 9 GB, it doesn't require that it will allocate 9 GB at the startup. It's just a guideline, not the exact allocated memory or cache size. So don't confuse it with that. So they both have a different concept, shared buffer and effective cache size. And this is a guideline, and that the shared buffer is actual memory required at the startup. So hence here, it should be large enough to hold most access table, but at the same time small enough to avoid swap. So workman, this configuration is used for complex sorting. Most of the time you need to sort your data, need sorted data from PostgreSQL. The one way is the crude way is just get the data from PostgreSQL and then sort it. You can't do that in this world because there is billions of rows are there. So you will send a query to the PostgreSQL to give you the sorted data. So where PostgreSQL have to sort it, it requires memory. It requires memory to sort. So where is the memory? So it is not the shape, it is a work mem. So it allows the work mem allows PostgreSQL to do large in-memory sorts. So each value, make sure each value is per session base. So what does that mean? Shared buffer is allocated once. When you set shared buffer, it will allocated once. But when you set work mem and you are doing complex sorting on X number of clients, then it will multiply with X. Like 3 processes are doing the sorting and you set it to 1 GB, then 3 GB will be allocated. It's not like shared buffer that it will be allocated once. It's a session base. And the session is using complex sorting, then it multiplies by that. For example, here, that means if you set that value to 10 MB and 10 user issue sort queries, then 100 MB will be allocated. So in case of merge sort, if X number of tables are involved in the sort, then X multiplied by workman will be used. So you can't set that very high value for that. So line in explain merge sort method, external merge disk. When disk is used, then you will get this kind of a message. Let's just put that message here for you. So how you set workman? I mostly recommend that people that when you are writing your queries, just don't set that workman and that kind of a thing in postgresql.com because you don't need to restart PostgreSQL. So when you know that this query is using a complex sorting, just set that value and then reset that value to the previous one. So here is the example. Set workman is equal to 2 MB. Explain, analyze, select static from foo, order by ID. So we are sorting using order by. You can see here the execution time 13724. So it's a 13-second. It's a millisecond. If you divide it to 1000, then you can get the seconds. So because the memory is 2 MB, so I in the bottom, I just change the work mem to 1 GB. And you can see explain, analyze, like static from the same query. And you can see the time is half of the time. So you see the time is reduced because you see the time is not consumed in extracting the data, because it's just a select static from foo. I'm extracting all the data from foo, so it will take the same time. But when we are talking about the extracting the data and then sorting it, then this will take time. So memory, you can see the memory, how much external mem merge or quick sort merge or different merge is used. It's all depend on PostgreSQL, which it will use. But when you change the work mem, you will get this sorting quickly. But the problem is you cannot issue this select set work mem 1 GB and this query, and you have a 10 this kind of clients and issuing the same command, and then 10 client will issue same command, then you required 10 GB of RAM in that case. So sometimes 100 clients, 200 clients, so you can't do that. So you have to do that carefully. That's why I'm just setting this value and reset that value, so it won't happen that you set out of memory. Now the next parameter is the maintenance workman. What is the maintenance workman? Maintenance workman is a memory setting used for maintenance task. So when you're talking about the maintenance task, what is the maintenance task? And what is the default value? The default value is 64 MB. And what are the maintenance tasks? Vacuum, restore, create index, add foreign key, alter table. So it's just for the maintenance task. So here is the example of that. Maintenance workman, checkpoint. I just write a checkpoint just to have everything set. Set maintenance workman to 10 MB, and then show maintenance workman. It show that it's 10 MB. And then I just created an index on table. It's a maintenance task on IDX foo on foo ID. You can see that the time is 12 seconds. And in the other example, I just maintenance workman is equal to 1 GB, and then I created an index on table foo, the same index. Most obviously, I created it on the fresh database on both examples, and you can 9 seconds had spent in that case, the faster than the previous one. So it doesn't matter that it's a 10 MB or 1 GB, it should be 10 times or 100 times faster than that. No, it is not like that. It's used the maximum memory it's required. So when its memory is requirement is fulfilled, then it will take its time. So maintenance workman is used for the maintenance tasks. So I just already told you what kind of a maintenance task is: the vacuum, the check with the creating the so that's how the maintenance task where this maintenance workman is used. Synchronous commit. This is used to enforce that commit will wait for a while for the wall to be written on a disk before returning status to the client. So like if you have a transaction and you just commit it, and I already told you it's written the wall file and wall buffers, and this wall buffer written to the disk. And when it written to the disk has a concept that we call some kind of a system calls that it returns success or failure. So there are two chances. One chance is we just write to the disk and wait that disk is returning success or failure. And in terms of if it returns success, then it's good. We will give you that your transaction is committed. And if you give error or fail, then we will throw the error. That's simple. But the problem is the performance. When we do that each and every time, just we write commit and commit and commit, and every time we wait for the success or error, and 99.9% chances are there we will get the success, and we are just waiting that it will return the success. It's not a good idea. So PostgreSQL provides you a way to control that behavior, that if you don't want to wait for the success, like just write on the disk and return the status, and you will get the error afterward, then just do it. Just write it and don't wait for the successor error. But this is a trade-off. What is a trade-off? Trade-off between performance and reliability. In that case, you will get the good performance because you are not waiting for that, but you are losing some kind of a reliability. There are 0.0001% or some hardware chances that you will get the error. So reliability problem is there. So increasing the reliability decreases the performance, and when you increasing the performance, decreasing the reliability. So synchronous commit doesn't mean synchronous commit introduce the risk of corruption. Synchronous commit is not introducing any kind of a risk, but risk of loss of data. So this parameter tweaking is not introducing any kind of a risk of data corruption. That your data will not corrupted, which is bad thing. Data corruption is bad, but if you are not waiting for your commit, error or success, the chances are there that you lost your data. It's just from wiki, so the hint is from wiki. Checkpoint timeout. PostgreSQL writes changes into wall. We already know the checkpoint process. In the remember that in the first slides where we are talking about the modules and everything, there was a process other than PostgreSQL is a checkpointer. That process flushes the data onto the data files. And where is the data files? Data file in the PG data directory. That's why I told you about the data directory. All the information are written into data directory. Exception are there when you have table spaces, but PostgreSQL write data into wall. Okay, and check pointer process flushes the data into the data file. So when this should happen, you're writing the data into wall. So when this happen, that this data is picked from wall and returned to the disk, it's all controlled by checkpoint timeout. Not only checkpoint timeout, other options are there, but checkpoint timeout is there. You can explicitly write checkpoint command that flush the data. Other than that, your database is running in background, and you set that parameter, that checkpoint on every 1 hour. So on every 1 hour, PostgreSQL will pick all the data from wall and write that into the disk files, data files. So what is the problem if you set too big value for the checkpoint timeout or too small value for checkpoint timeout? If you have a too small value like 10 minutes, so every 10 minutes it will flush the data into the disk file. So performance impact, a negative impact performance. That because it's too much IO. So what is the solution? Set this value too long. But if you set this value too long and your database is crash, then it will take a long time to recover. So bigger value of checkpoint is a drawback, that your recovery time will increase, and you will get the good performance. But the smaller value of checkpoint has a negative impact that on performance, but recovery time is very fast. So you have to choose in between. So now I think we have discussed the major Linux tuning, PostgreSQL tuning parameters. So now I'm going to the next topic, which is the Linux tuning for PostgreSQL. So input and output handling of PostgreSQL. There are three kind of a buffering in operating system or application or in computer science. One is direct IO, second is a buffered IO, and third is a double buffer. Direct IO mean when in your application, you write an application and you directly write onto the disk, which is called direct IO. And buffer IO mean you write into the kernel buffer and kernel will write that buffer to the disk. And what is the double buffering? You write your data into your own buffer, and then this buffer is written to the kernel buffer, and then kernel buffer is written to the disk, and this is called double buffering. PostgreSQL believe on double buffering, and you can see it. PostgreSQL believe that operating system knows much better about storage and IO handling. It's some kind of a true and false also. When you're talking about, because PostgreSQL has its own buffer system, and it also rely on Linux or operating system kernel buffering. So it's using both the buffers. So what is the advantage? The advantage is this, that Linux operating system knows its storage, IOs, and everything. And PostgreSQL on buffer, PostgreSQL knows its own buffer and pages. What is the drawback? It has two drawbacks. It increases the memory usage. And the other problem is different kernel behave differently. You cannot predict actually. Like if PostgreSQL doesn't rely on Linux kernel buffer, it has its own buffer, then it behave on Windows similar to the HP UX or Solaris on every operating system. But it behaves a bit different because every internal buffer management system is different. So settings are different. So it's rely on kernel buffers. Just make sure that it has own buffer, and it also rely on Linux kernel buffer. So virtual memory, every process is given the impression that it is working with the large contiguous sections of memory. When you're writing your application have a feeler that it has a contiguous large memory area where it can write and read. But it's not possible because you have one physical memory. But virtual memory give an impression to the application that it is written to the actual memory. So how it works? It works using a virtual memory, a page table. So page table are used to translate the virtual addresses. Your application is using the virtual addresses, and page table translate virtual addresses to the actual physical addresses on the RAM. Why I'm talking about this? And I will let you know in the next slide. So when you're talking about the virtual address and the actual physical address, then there is a concept of translation look aside buffer. Like that you have this information into the buffer or not. It's hit or miss. If a match is found to the physical address of the page, it return TLB, translation look aside buffer hit. If match does not found, then it's missed. So what does the transaction look aside buffer do? It reduces the time to access the user memory location. So we have a buffer, we have a virtual addresses, we have a physical addresses, and we have a translation look aside buffer, which reduce the time to access the memory location. So we, for this translation look aside buffer, we need, this is a buffer, and keep this mind, this is a buffer and we require this kind of a buffer. So if you have in the right side, if you see the diagram, if we have a very small pages of data, that means we need very large TLB, and we have a very large TLB, then we are again wasting over time to accessing the page. Here we have a page, we have a transaction look aside buffer, then the disk and the physical address. So if we have a very small pages, then we need a very large translation look aside buffer. This is expensive. So now come to the actual, that's the theoretical stuff. Now we to practical stuff here. Different operating system has a different size of a buffer. Linux has a concept of a classic huge pages and a transparent huge pages. BSD has the super pages. Windows has a large pages. So normal, and the Linux has a 4K of pages. In the first slide, I told you that Linux has a pages of 4K. So if we have a 4K pages, that means TLB will be very large enough. So how we can reduce that? So Linux has a concept of huge pages and transparent huge pages. So PostgreSQL has support for that. So it doesn't have a support for the super pages, for the Windows large pages. We are talking about the Linux. So it has a classic huge pages support in PostgreSQL. So Linux page size is 4K, and memory modern processors support other page sizes. Like we have a 256 GB of RAM. Then if you can see, the huge page size 2 MB and 1 GB is supported. So 4K will be there. That doesn't mean that Linux will drop the idea of 4K of pages. Linux will use 4K, but Linux will also have a 2 MB or 1 GB huge page. So now, how to check what is the size of huge pages in this? So just catch it, the proc mem info. You can see the total memory and everything, then 4K, and yet you can get the idea. And the first line you see after the mem total, huge page size, it is 2 MB. So it can be 2 MB or it can be 1 GB, not both. So you can set it to 2 MB or you can set it to 1 GB. No other options available, except the future is that 1 terabyte huge pages are also available. But right now, 2 MB and 1 GB. So you cannot set 3 MB, 4 MB. It's just 2 MB and 1 GB. And you can set how many huge pages your system can have. So here you can use the command sysctl -w vm.nr huge pages is equal to 256. I just said 256 huge pages of 2 MB. So now you set the 2 MB size of the huge pages and number of huge pages are 256. How PostgreSQL will use that? And this is the similar and the previous statement that how you change that to 1 GB. In the grub, just open the etc default grub file and just default huge page size, and huge page size is 1 GB instead of 2 MB, and just write it there and just update the grub, shut down your computer, restart it, and when you run this command, and in huge page size you will see the 1 GB instead of 2 MB. So now comes to the PostgreSQL. So everything in Linux and I have done. So now we are back to the PostgreSQL. In PostgreSQL, just open postgresql.conf file. You will see huge pages is equal to try. What does that mean? It means Postgres, when you restart your PostgreSQL, PostgreSQL will try that you set huge pages or not. For Linux has support for huge pages or not. If it has, PostgreSQL will use that. Try me, it will try it. If PostgreSQL will have, Linux has the huge pages support, it will use that. Otherwise, it will not use it and properly run. But you can set it on. What is that on mean? On mean when you restart your PostgreSQL, it will check Linux has huge pages support. If has Linux support, then it will use it. If Linux does not have a huge pages support, then it will not start. PostgreSQL will not start and give you the error that huge pages is on, but huge pages support is not on in Linux. And if Linux has a huge pages, but you really don't want to use it, just write huge pages is equal to off. So Linux has huge pages support or not, you set it on off, it doesn't matter, because in postgresql.conf file you set huge pages is equal to off, then PostgreSQL will not use huge pages. So when we're talking about the 2 MB huge pages and we are talking about the 1 GB huge pages, there are two kind of huge pages. They are 2 MB. Then Linux introduced a new concept, which is called transparent huge pages. You know, PostgreSQL has written a code for to use the huge pages. So when your application want to use the huge pages, it just write the data, uh, write the code for that to use that. But Linux introduced a transparent huge pages that your application don't have to worry about the huge pages. If operating system support that, that operating system will use that for your application. That's it. But here you can see anonymous huge pages is 2 MB and it can be different. But the problem is all the database has this theory that transparent huge pages are not good for the database. You need to disable it. I also benchmark it and find no benefit, even some cases, bad results when transparent huge pages are on. Even the other databases, blogs you can see on the internet, they are also discouraging to use transparent huge pages. So here are the commands where you can disable transparent huge pages on your operating system, and that's it. So just these two configuration parameter, you just change it, just put never in there, and then restart, and that's done. That's another parameter of Linux kernel tuning. That is a swappiness. So to control the swappiness of your system, that it can affect, because swapping is actually is not too good for you, because it introduce the IO, and when you introduce the IO, then it hit the performance. So swappiness used to control the swappiness, swapping pages to swap memory into the RAM and into the disk. Okay, so this is a Linux behavior. So this parameter can take anything from 0 to 100. Default is 100. So when you set higher value, then it means it will aggressively swap RAM into the disk. And if you set this value low, it will not aggressively swap. So you can set that value 1, that means very low swapping. And you set that to the 1995, it will do a lot of swapping. So you can control that. You can get really good performance if you have a large memory, and you don't have to worry about the swappiness. Just set this value 1 and you can get really good performance on that. So overcommit and overcommit ratio. Sometime in an application, when you're writing application, you don't require too much memory, but you ask the operating system to give you the memory. So application acquire memory and free that memory that is no longer needed. But in some cases, an application acquire too much memory and it will not release it. And when other application also need memory, then it out of memory error message comes and it kills. Sometimes you have seen that PostgreSQL also killed by the OOM. You see, it's a OOM, it's a killer, out of memory killer, and you set the out of memory error message and your PostgreSQL database server is crashed, killed. So there are 3 options here. One is heuristic, which is the default value, 0, and one is allow overcommit anyway, and this is the dangerous way. One, when you set, it will set that the one overcommit the memory, and when that memory will be used and kernel does not have that kind of a memory, your application will be crashed. And 2 is the best value for PostgreSQL because it controlled by 2 parameter. One parameter, don't overcommit, or you can say overcommit between overcommit ratio. Like don't overcommit beyond the overcommit ratio. You configure 2 parameter. In first parameter, you put 2 overcommit memory. That means you can overcommit, but don't overcommit 50% of your memory. Eco 50 ratio. If you have a 100 GB of RAM, for example, and you set 50 and 2, that means it will not overcommit other than 50 GB. So this is the best option for you. So there is 2 other parameter. VM dirty background ratio is a percentage of memory filled with dirty pages that need to be flushed to the disk. So when you're writing your data onto the disk, then dirty pages come. So how you can control this behavior? Flushing is done in background. You need how much memory filled, then this dirty buffer is flushed to the disk. You can control this behavior. Its percentage is 0 to 100, and this is done in the background. Your application will not stuck here. The value is parameter is from 0 to 100. Like if you want to do that flushing to disk too often, then you can set it the low value. And you want to set to the not too often, then you set this value, higher value. That. I'm not talking about this. It's similar to the background ratio and background bytes, but it is done in the foreground. Your application will stuck at that time when this flushing is in progress. Its value is same 0 to 100. So I think Linux kernel parameter tuning is almost, I discussed the most of the parameter here. Maybe you understand it that. So PostgreSQL recently is too much community is too much working about the parallel query, how you can do the parallel scans and something like that. So they provide some parameters. So I want to discuss some of the parameters here. How parallel query works, we will discuss that. When can parallel query be used? Parallel plans, parallel safety. We will discuss how parallel query works. And secondly, we should when can parallel query be used? What is the parallel plan? What is the parallel safety? So we will discuss these parameters here. So, so before going to the actual see how parallel query works and something like that, there are some configuration parameter. We discussed the same PostgreSQL.conf file, and these parameters are related to the parallelism. So just I put it here. So max worker process sets the maximum number of background process that system can support. This parameter can only be set at server start. So you said that the maximum number of background process. This is not the number that your parallel query will use that. It is the maximum number. Maybe your parallel query will use only 2 worker process, 3, 4, 5, 6, 7, 8, but it can't be 9, 10, 11 because your maximum limit is 8, but you can change it. You have a bigger system, you have a bigger multi-core system. You can set it to a higher value here. And they set maximum parallel worker per gather. I will let you know about what is the gather. So sets the maximum number of worker that can be started by single gather or gather merge node. And max parallel workers set the maximum number of workers the system can support for parallel queries. And dynamic shared memory type. Parallel query requires dynamic shared memory. So this parameter cannot be none. This can be in one of these POSIX, SysV, Windows, and map. So you have to set one of these values. And the next one is the parallel workers. Why it's blue? Because it's not PostgreSQL.conf file setting. Actually, it's when you are creating a table, you can set how many parallel workers this table can use. So we will see in the next couple of slides. So how parallel query works? Configuration we already done. So you can see here, explain, analyze, select count static from foo, and you can see worker planned and worker launched. Maybe when you run your query, you see this kind of a behavior. Oh, sorry. You can see this kind of a behavior. So why? You have to check 2 parameters. 1, max worker processes. 2, max parallel workers. It is possible that these are 0. And that's mean it's only planned, it's not launched because the value is less than that. So the next one on the right top corner, you can see the worker planned is 1 and worker launched is equal to 1. In that case, you have to check the value of max worker per gather and parallel workers. Why it's planned 1 and why it's launched 1? It should be more than that. So maybe chances are there that's, but I'm just giving you the hint that you have to check max parallel worker per gather and parallel workers in that case. And the left bottom, you can see a query, explain, analyze, select count static from foo, and you see worker planned 1 and worker launched 1. And it's just a sequential scan. So what I done here, I just alter table and set parallel workers is equal to 2 for that table. And again, I run the same query and you see worker plan 2, worker launch 2 for this table. It is just for this table only. So what is the gather and what is the gather node? Just talking about this. Here, when we're talking about the parallel sequential scan, worker plan, worker executed, then there should be a node that this should gather all the information coming from the worker threads. So it should be in one result. So this is the gather node in which all the information comes and this make a single output result for you. In the next diagram, you will see how it looks like. So select static from foo pg bench accounts where filler is equal to like this. You see the gather, worker plan, parallel questions can happen, and you can see the data. When can parallel carry be used and when cannot be used? Simple. Number of background is should be less than max worker process, and you can see I'm not reading all of these, so I just put cross and tick here, so you can see where you can use, where you cannot use. So parallel plans. So we're just talking about the parallel queries. Now we're talking about the parallel scans. In parallel scan, parallel question scan, bitmap scan, index only scan, then parallel joins, parallel aggregation, parallel append. Just here is the example. I want to discuss a big detail because I already discussed much about the parallelism. Parallel question scan. If you see here, the create table, I just created a table and then I explained select static from foo and then some where condition. You can see the planning time, and in the bottom, you can see a planning time a bit increased, but the query execution time decreases. The execution time is 1.6 second, and you can see 0.4 second when the plan and the worker launch 4, almost 4 times. It's not necessarily that it's 4 times or not. I'm not talking about the 4 times or 2 times, because the 4 it's faster than the where sequential scan without parallelism is invoked. When we invoke the parallelism, I intentionally disable parallelism in first query. But in second query, I intentionally enable parallelism, and you can see the performance boost in the execution time. And on the right side, you can see the normal process, stable process is reading block 0, block 1, block 2, is serially reading that. But in the parallelism, you can see is there is a leader, there is a gather, and there is a for worker, and then table is reading. The leader is the process, is the one, it can be a one of the worker that accumulate all the information using gather node into one result. That worker 1, worker 2, worker 3 will read the data from the table, and the gather node will gather that, and leader will give you the actual result of the final result of this select. So the upper process table, you can see it's serially reading. In the bottom diagram, right bottom, you can see is reading the parallel. So this is how parallelism works. So here is an example of parallel bitmap scan, heap scan, that how leader is using. It is an example. So I think so. Parallel index scan, because I just discussed that how the parallel sequential scan is done. So then I want to let you know that how index scan is working. So here I have an example explains like this from foo where ID is less than something. So parallel index only scan, just skip over the only just index scan using IDX, and worker plan is 2. So in this case, if you see in the diagram, there are two workers 0 and 1, and they are both reading the data underneath. Just don't confuse that, because I'm not relating this data with this diagram. This diagram is just to show you that it is reading the a B tree index, a B tree index, how B tree, this is a B tree diagram, and how worker 0 and worker 1 is reading data from B tree index. So this is the main thing, that worker 0 is reading the some part of the B tree index, or worker 1 is the other part, and then the gather node is gathering that data, and the leader node accumulate the data for ourselves. Similarly, for the bitmap heap scan, sorry, and similarly parallel joins. So if hash is too big, then parallel hash is thing, the merge join, that you can see the parallel hash join. I have the query for you, some description here. And the parallel aggregation, you can see we have a worker 0, worker 1, worker 2, worker 3, worker 4. We have a partial aggregate node, and then that aggregate node is doing the sequential scan on the data parallel, and the gather merge node gathering all the data and finalize the aggregate. And then we master worker will gather all the information and make the result for us. Similarly, parallel append, parallel labeling. So this is not the topic of parallelism, how parallelism work in PostgreSQL, but the purpose to have parallelism in this tuning session, because I want you to learn you can configure the parallelism in PostgreSQL. It's a new feature. Then you can, I have to introduce this. If you want to have more detail this parallelism, then YouTube Percona channel have the detailed parallel query optimization and tutorial available there. You can see, and you can see there, but I have this slide for you to discuss this. And then we have some kind of a parallel index creation. It's also that you set the max parallel maintenance worker is 8, and then just create an index, and it will create index in parallel. So only B tree parallel build is supported. So for the blog post, for the tuning PostgreSQL database parameter to optimize performance, you can see this blog. Tune Linux kernel parameter for PostgreSQL optimization, you can see this blog. And thank you. And everybody save the date for Percona Live Online, May 12 to 13, 2021. Call for paper is open. If you want to present in that conference, it's online conference, and you can submit your papers there. So I think we can have some questions.
All right, thank you, everyone. I'm going to drop that link into the chat for the call for papers for Percona Live. So if you're interested, we are taking submissions. So yeah, feel free to check it out, and we'd love to have you involved. So we have about 2 minutes before we hit the 90-minute mark. So I do want to respect people's time. So I'll ask a couple questions, and then we'll address the rest of them. I'll send them to Abrar after this and have him answer them offline, and we'll create a blog like I had mentioned. So here's one that came through. I'm having problems migrating from Oracle to Postgres. One of the tables with the CLOB is taking a long time to migrate. Is there anything in particular that needs tuning for a table with CLOB? Is that a tough one?
No, it's not tough one. Actually, to migrating the table from Oracle to PostgreSQL, it all depends what kind of information it has. CLOB and this kind of information, it will take time, but some kind of a bulk loading will help that. But it's not about the, it's a direct answer I can say. If he can send the directly query to me what kind of information it has, I can suggest him some kind of a tool which can be used to have to reduce the time.
Okay. Well, we just hit the end of our minute. So I'm going to, on that note, I'm going to let everybody go. And Abrar, I'm going to send you all the questions. We did get a couple that came through. So please stay tuned. We'll send out an email recording in the next 24 to 48 hours, and then we will try to get that blog together in another week or so. That tends to take a little bit longer. But, I appreciate all of you attending today. And thank you, Abrar, for such a great session. And I hope everyone has a great day, and I will chat with you next time. Thanks,
Yeah.
everyone.
Thank you, everybody.